Unit 12, we're going into electricity and magnetism. So today's video is going to be about what is electricity, and we're going to do a little bit of math with it, okay? So first off, let's talk about the different types of electricity. Static electricity, accumulation of excess charge. Excess charge. So that means you've got a lot of positives or negatives going on. That's static electricity, and those what happens so if you rub a balloon in your hair, what's happening is those electrons and protons are being moved from one object to another, so then you're able to they're able to be attracted to something else. Okay. What's happening with those charges? So this is one of those elementary topics that you need to make sure you still remember. You need to make sure that you know like repel, opposites attract. So if you have a picture of two negatives here, they're going to go away from each other. If you have two objects that have a positive charge, they are also going to go away from each other. But if you have a positive and a negative, they go towards each other. Likes repel, opposites attract. Now, surrounding every electric charge, there is what's called an electric field. So if an object has a charge to it, it produces this electric field, which causes either the attraction or repulsion. So this is what's causing the previous slide. Now, you've got to be able to draw these. You don't have to draw this crazy mess, okay? So what you need to draw is you've got a positive there and a negative here. You need to make sure that you know that the electric field is coming off of the positive and going towards the negative. Off of the positive, going towards the negative. Okay, off the positive towards the negative. It comes in. It surrounds those two objects. Okay, now this is why there's attraction there, because it's going from the positive to the negative. Now if you have two positives, it's going off of the positive, but there is no negative, so it's going to go like that. So positive here is going to go away from that. And same thing here, since it's going away from it. And what happens here, it sort of forms this like a spring kind of thing. These electric fields form a spring from each other. Therefore, they're not trying to get close to each other because that springiness is getting in its way, causing them to repel. Electric charge, how it happens in the first place, you have conductors and insulators. A lot of vocab going on here. So a conductor is a material where electrons are able to move easily. So material electrons move easily. Insulators, the electrons are not able to move easily. Electric charge is all about those electrons and moving from one object to another. Conductors allows them to move. Insulators are causing them to not move or to at least slow down. Okay? How to actually charge objects. So charging the objects. There are two ways to do it. Conduction, we've used this word before. It's the same thing as what it was with heat. So we're using it again with electricity. It has to have contact. The two objects have to touch each other. So transferring charge by touching or rubbing. Touching or rubbing has to occur. So rubbing a balloon in your hair, you're charging your hair and the balloon at the same time. You're having a transfer of electrons going on. Induction obviously is no touch. It just has to be, is caused by a nearby charge. A nearby charge causes it to get charged up. Okay. Grounding. It's literally what it sounds like. You are grounding, connecting an object to the earth with a conductor, so excess charge will not build up. Every single house has to have this. Can you imagine having a house without a ground? And your house would just build up electricity over and over all the time, and eventually what would happen? Okay, there has to be a place for excess charge to go, or there will be some kind of electric fire or things like that. Okay, so grounding is you have a conductor that's literally placed into the ground for the excess charge to go away. Okay, Now we're going to slowly get into our math here. Again, a lot of vocab. Electric current. Electric current is the letter I. I would not start off with that. So electric current is the letter I. This is going to be important when we get into the math. Current is I. This is the net movement. This is the movement of electric charges in a single direction. So movement of electric charges. Its units are in amps. So this is the letter it represents in the formula. Its units are amps. Okay? So another way you could write that is I is current and its units are in amps. Definition is the movement of the electric charges. Without current, we would not have electricity. There are two types. You have what's called DC and AC. DC, it flows in one direction. Example of this is batteries. Alternating is AC, so it's exactly that. It reverses directions. This is what you use in your house. Okay, so an outlet. All right, next one is potential difference. So potential difference, I'm gonna kind of rewrite this here. Potential difference. One big long word here. Its letter is V. Good thing though is that its units is also V. So the letter that represents it is the same thing as its unit. So potential difference is the letter V. Its unit is V. Definition here. Ability to move electric charge through a resistance. So this is the difference. You gotta know the difference between here. Electric current is the movement of electric charges. Potential difference is the ability to move through a resistance. We'll talk about resistance in just a minute. A battery can provide voltage difference in a circuit. So it's something that's pushing the current. Without voltage, there is no current. This is the voltage is what's actually pushing that electric charge through the resistor. Increasing voltage means more current. So the higher the battery, the more current can go through the circuit. Okay. Last one here, resistance. I'm going to rewrite this again here. Resistance is represented by the letter R. Its unit is what's called ohms. It can also be written as like a horseshoe. Okay, so resistance is the letter R. Its units are in ohms. It is the tendency to oppose the flow of electrons. So it's exactly that. If you're being resistance towards me, that means you are trying to not do what I'm telling you to do. Resistance in the electric current is the same thing. It's opposing the flow of electrons. Something is stopping those electrons or slowing those electrons down. Things to remember, and there's not really too much I can shorten here. Insulators have more resistance, so insulators, more resistance. Thinner wires, longer wires, hotter wires. So these are the ways to have more resistance. Okay, so to increase resistance. Let me write that so you can increase resistance. These are the ways to increase resistance. So using an insulator, thinner wires, longer wires, hotter wires. So let me talk about an analogy here. Thinner wires. Why does a thinner wire have more resistance? So think about the hallway. Our hallways are pretty big now. Can you imagine having a hallway that's only 3 feet wide and having all the same amount of students trying to get through it? There'd be a lot more resistance. You would not want to go down that hallway. The electrons are the same way. The thinner the wire, the more resistance. The longer the wire. So can you imagine our school being like miles long and going from one class to another? You would get extremely tired to do that every single day. So the electrons are the same way. The longer the wire, the more resistance. The hotter the wire. All right, so imagine an extremely like 115 degree day and trying to do work outside. You're going to be resistant. You're not going to want to do it. The electrons are the exact same thing. All right, so insulators, thin wire, longer wire, hotter wire increases resistance. This summarizes everything that I've talked about with what the letters mean. So I is your current. It's in amps. Voltage difference, same thing as potential difference, is in V. Resistance is R. Okay? So this brings us to our formula right here. All right? So if you want to summarize what I just said, V is voltage or potential difference. Its units are V, so that should be easy to remember. I stands for current. Its units are in amps. R stands for not ohms, sorry, stands for resistance. Its units are ohms, or it's written as the Greek letter. Okay, now let's talk about our little triangle, because you know you got to do it. I and R are already multiplying, so they go to the bottom, and voltage goes on top. So let's do an example. I already have the triangle there for you and everything here. So a light bulb with a resistance of 2 ohms, so you got a little horseshoe, that's what I was talking about, that is R. Current of 4.5A or amps, so that's going to be your I. When hooked up to a battery, what is the voltage? So you're looking for V. So what is V? So you shade in V. V equals I R. All you're doing is multiplying. So 4.5 times 2, which is 9 volts. So you need a 9-volt battery for it to work. Second example, all right, 5 horseshoe looking things, so that's our resistance, is plugged into an outlet, voltage difference of 120 volts, so V is V, so that one should be an easy one. Everybody should be able to identify that V. Current, what letter is current? We are looking for I. So we're looking for I. So here we go with the triangle. We shade in I, see how V is on top of R already. So that's exactly what's going to happen in our formula. So all you're going to do is V, 120, divided by 5. So 120 divided by 5 gives you 24 amps. And there you are.